Welcome to the Modern Application Development Screencast. In this short screencast, we will learn how to add full text search to our application. Before we start, open the following applications on your Ubuntu desktop so that you can work along with me. A browser, Firefox or Chromium is fine, text editor on IDE or terminal, and a DB browser. We have already built an application with simple articles and listing. Now let's assume that we want to add a feature where we are going to search keywords in article content and give a result based on that. To do that, let's look at the structure of the tables. We have article table. Let's say we want to build a search on a title or content. Let's assume content. And we want to go through the rows and see which content contains the specific keyword, filter out the results, and give the results page. A query would look something like this: select star from article where content like percentage and whatever our key is. Let's say our key is flask, we can add that, and when you run the query, it will give the result to flask based articles that we have, which has the keyword flask in the content column. It will give us the result and we can use in our result page. Now let's build a page for it and the controller for it. Let's assume we are going to have a page called search, and we are going to pass a parameter called q and like flask, and that would give a results page for us. Let's build this. It doesn't exist, as you can see. You can start with adding a controller. We'll add a controller called search. Let's add that. So it would be somewhat like this. So I'm just going to copy paste a bit. So it will be called search, and it will be just get. Right. We won't be doing articles.findAll. We'll be just filtering it based on like and getting the parameter and based on like keyword. So I'm just going to get q from the request, and from the query by adding percentage on both sides. I'm going to make it simple percentage, right? And then do a like query on article tables. Right, let's do results article.query, filter article.content, which is like q, which is like query, and get all of them. This results will go here. We can even pass q to the page so we can show what was the query that was searched for, and we are going to call this the template as results instead of articles. Okay, let's create a results template. Okay, which will be very similar to our articles. So I'm going to copy paste that. I'm going to change search results and change the header to search results and the header jumbotron to search results. Okay, and it won't be articles, it will be results, and I'm just going to print the title. Right, when I'm not going to do anything else, just print the title. Okay, now let's stop this, restart the server and see. Okay, it has restarted already. Started again, just refresh. Okay, now we have the title of the articles which has. So let's do little bit of change. instead of doing this, just make it an li, make it an ordered list. So in future we might even add a link to this to lead to specific article, right? We'll fill up this page because we don't have a controller to get article by ID. We won't do it now. Maybe we'll do it in future. So if we do, this is how it looks. This is the search result. Now the problem is, if I search by, let's say, small f, or let's say okay, let's search by some other word and like add or go to a database, let's say we want to search by my and article both, right? Let's search by my. That should work because it's giving all the things that has my plus article. We won't be able to get that because the like doesn't support that. Or let's say if I give capital my, it gives, which is good. Let's do some other thing. If I want either my search or my content has either my or new, or either my or relationship, I can't do or class. For example, I can't do say my or something else. Let's say relationship, right? I can't do that. Or I want to get all the articles that's just starting with Flask and not contains with Flask, which means I can't do starting with Flask. For example, if I give Flask, it gives me both, which has every contains Flask, but not with only the second one, which starts with Flask. I can't do any of those extra conditions like or and, or I want an article content or an article which has both Flask and documentation, like say Flask plus documentation or Flask and, right? We can't do such queries here. And these queries, using like, which we are using here, is also very, very expensive. You can actually run and explain on them and see how does it, the query explainer does it, and you can check how expensive those are. So to actually kill all these negatives, or to actually overcome all these restrictions of just using the like, SQLite and many other databases too give a functionality called full text search, where it creates indexes in a very different way in a separate table, and we can query that with lots of keywords. That will make it easy for us to do the searching, and these searches are also very fast and less resource consuming, because they are meant for doing searches. So in SQLite, the new extension is called FTS5, and we can use that to actually build our search in a very flexible way that makes our search scalable, faster, and and useful in many ways. That's why we're going to use FTS5 and build this same search feature again, right? Let's do that now. Okay, so we're going to keep this as it is, and we're just going to build the FTS5 based search. Now FTS5 has a documentation page. You can go through that in detail. Basically what it does is it creates a virtual table for a table that you want to create index on, and then you can link it to actually the table that you want to create index on, and then you search on this virtual table to give you the search result, so that the search results are faster. Now it kind of supports different kinds of tokenization, different kinds of splitting, so that search becomes faster, and you can do various kinds of logical searching and logical conditioning, all of that. You can go through this documentation to get more details. At the bottom of the page, you can also see that there are various type of conditions that you could use to match the rows. You can do first token or starting with, or an AND clause with plus, and actually use an OR class, or you can use near based on the kind of queries that you write, and also many other, like not clause, which contains one, doesn't contain other, or which contains both the query parameters, or which contains one or the other query parameters, etc., etc. There are many ways to create the search, and this will make your search very functional, closer to what you would have experienced on the web or any other site, unlike just using a like. So let's create a table for our article table. Now before we start that, we should make sure that the DB browser that we are using also supports FTS, because it's a module. It should have been compiled with that, and also the Python has FTS5 enabled. So to check that, we can just run the query pragma module list or pragma compile options. So you can just run it here. Now you can see what all is enabled at the compile time, what all the modules has been enabled. It has FTS3, but it doesn't have FTS5. We can install a DB browser which links to the latest module, and or you can load the module, etc., etc. I'm not going to do that. I'm just going to use another open source DB browser or database browser. So I'm going to close this and open that. It's called SQLite Studio. You can go check it. It's a free again and open source DB browser. I've opened the same database here again. I'm going to run the same query here just to make sure how it looks. So you can see it has FTS5 enabled. So we can run all the FTS related or full text search related queries here. Similarly, you can also test your Python, whatever version you are running has FTS enabled, etc. I have a simple code here to check whether the Python built-in SQLite has FTS enabled. When you run it, actually, if it's enabled, it will print FTS is enabled. Just going to mark other things. Okay, let's run this. FTS is enabled. You can run the same thing locally. To test your local setup is also FTS enabled. FTS5 enabled very specifically. We're going to use the 5, FTS5, right? So you can run it locally in your Python thing also to just double check. I've already done the check, so I'm not going to do that check anymore. And now once that is done, in your browser, we are going to create the virtual table here. So let's do that creating of virtual table. I'll explain it to you what it involves. So here we are creating the virtual table called article search, where we'll store all our article indexes, or it's our search table. Using FTS5, we are going to use only title and content for title column and content column for our searching. These are the only two columns on which we will search. This content is equal to article is linking of the table article, because this article search is linked to article. That's what this notifies. then content row ID. This article search doesn't have any primary key, but it just has a row ID. Now we are mapping the content row ID, that is article search's row ID, to article ID of our article, right? So that whenever we query this, we also get article ID so that we can back map it to article. And the tokenizer is Porter Unicode 61. So you can read about this more on this table, on this documentation page, which has a lot of details about it. Right, tokenizers. Not going to explain that much, but it's used to tokenize the content and index it so that we can search. You can read about Unicode as well there. Now let's create this. So it has created the virtue table and related tables for it. Now once that is done, the way this works is whenever you insert a row into an article, you also have to insert a row into article search, so that the index gets created and then you can search on the index. Now that is very, very painful, because every time you create an article, you have to create one in article search. Every time you delete an article, you have to delete an article search. Every time you update an article, you have to update an article search. You have to manually keep sync of these two. Now that becomes very painful. So what we're going to do is we're going to use indexes, or sorry, what we're going to do is we are going to use triggers. You would have already studied in your DB course what are triggers. There are, based on an action on one table, we can perform some actions on some other table or on the same table. Those are called triggers. Now I'm going to create trigger on insertion of an article. So that's this. So I'm going to create a trigger called article auto insert. It's after inserting a row in article, what it does is it also insert a row in article search. You can see that I'm creating the trigger which is based on insertion in article. What it does is it creates an article in the article search. It has row ID, title and content as a column in article search, which picks up from article ID of a new article that got inserted in article, and title of the new article and content of the new article. So this is the trigger we have set up, right? So it got executed, it got inserted. Similarly, I'm going to do one for delete, right? Here I'm going to create a delete trigger, because as soon as the article gets deleted in article table, we also want to delete in article search. That's done by sending delete parameter in a special column also called article search. So we are going to run this. Similarly, we're going to do one trigger for article update. When the article gets updated, it deletes the row from the article search first and then inserts again, because the article search virtual table doesn't have an update concept. Hence we are going to delete first and then reinsert with the new content, right? Now we have set up all the triggers, but this is not going to come into an effect until we insert next time or an update next time. So I'm just going to rebuild the index for the first time. Here I'm just rebuilding the article search. All right. So it rebuilt all the articles. Now we can do some kind of queries on article search based on the extra keywords that we have got to match the things. Let's do that. So for example, this. Here we are using the keyword called match, which actually matches a column. So here we are doing column match. Select row ID star from article search, where content matches flask star, flask and anything that follows. Now if I run this, you will get anything that has flask in its content followed by. Now I can also start only with Flask. So for example, in that case, it will give only row 2 as the result. There you go, gives you only row 2. You can also just do an AND clause. For example, let's see what are the rows available. Select star from, right? Let's say I want a row that has both dummy and content, or dummy and article. Okay, so that I can do by running a query like this, where it matches the content which has dummy and content within it. So that will only give me this, right? Let's run that. So you can see dummy and content is the one which you got as an answer. Let's go back and see some other conditions, right? Some other OR conditions. Select star from article. Okay, now let's assume that we were searching for something that has keywords my or Flask or content, right? So that can be written like this, right? This would have my, which means it will give this and this, or content, which this and this, or Flask, which means this or this. So it will give you all 4 rows, right? It gave you all 4 rows. So in this way you can build your own queries with logical or binary logic. And so there are many more. You can go through this here. For example, here you can use not class, which means you don't want to have here full syntaxes here. You can go through them and build your own search based on that. Now we have seen this, we have executed this here in SQLite Studio. We want to bring this back to our SQLAlchemy. So in SQLAlchemy, we'll go to model. Now we'll define another model class called article search, which will map to our virtual table, right? So that would look like this, right? Table name, article search, row ID, db integer, primary key is equal to true, because it's there, and then title and content. It's not related to any of the other things. There's no relation. This is just a virtual table, and this is just a dumb mapper to that. Now we can use this in our controller. It will just import that. We'll remove this. We don't need this percentage part of it. Instead of writing this query, what we'll do is we'll do a match query, right, which will look like this. So I'm going to just mask this article.query.filter, and then article content like query and all. Instead of that, we are now going to search an article search, and do content. We are going to run an operation called match and pass the parameter q to it, whatever they are going to send, so that we kind of give the users the ability to build a query for us, right? Let's try if it works. Okay, restart it. query is not defined. Oh. Okay, let's restart. Okay, it started. So you can already see that for Flask and documentation we are getting result, right? We'll try the same query that we tried before, which is my or content or Flask, and see whether we're going to get 4 keywords, 4 articles as result. Here you got 4 same articles as results, right? Like this you can build much more detailed querying capability. Now you can also restrict and add security restrictions to user, so he doesn't query on other columns or other things. But if you build your search table in smartly, where you want to give only publicly searchable columns, then you can expose the match keyword to the user, get the query directly and then run it. Or you can do some kind of cleaning it up before you query it as well. If you want to give a different logic to user, and then convert into match query inside your controller and then use it as well. Now as a next step, what would one do is, instead of actually doing this, they can actually do / article and then just add row ID here. Then if you see, it becomes real URL, and then you can actually develop that page too, where you actually can go to the specific article page and stuff like that. Now you can also improve this page by giving parts of the content here and highlighting parts of the content where the keyword is found. FTS5 allows that also, where it returns parts of the content where it is mapped, so that you can highlight where in the content the keyword is found, etc., and you can build your search like that. So this is how we build full text search in using FTS5 in SQLAlchemy and Flask. You can also do the same thing using PostgreSQL's full text search too. But since we're using SQLite, we're just going to concentrate on that. Now there are other ways to do this also. You can also use external system to build indexes for searching. There are many other specifically built databases for search and search with some great search capabilities. You could use that too. But when you have an option of full text search, I think for majority of the applications, full text search should work well. Thank you for watching. Bye.